mynews.studio.
Picture this, an AI quietly scanning your health records, picking up signs of cancer or Parkinson's long before any symptoms appear. Could early warning systems like these really change the way we practice medicine?
Today is October 22nd, 2025. Let's get right into it. AI is starting to reshape how we detect diseases early. Cancer, Parkinson's, even autism. Diagnoses are coming sooner and with more accuracy. But what does that actually mean for patients or for healthcare systems already under pressure?
It's a substantial shift. Take cancer, for example. In the UK, with the help of AI tools, primary care cancer detection rates have jumped from about 59% to 66%. That translates to thousands of lives potentially saved every year just by catching cancer earlier.
That's quite a leap for public health. But how are these AI systems actually working? Are they just reading X-rays, or is there something else going on?
It's definitely more than imaging. The latest initiative, the Cancer Data-Driven Detection Program, brings together health records, genomics, family history, and even behavioral data from 18 UK institutions. The aim is to build statistical models that estimate a person's risk for different cancers.
So instead of generic screening, it's moving toward a personalized risk assessment. If someone is flagged as high risk, they get more targeted screening. Is that how it works?
Yes, that's it. As Professor Antonio, who leads the program, puts it, the real hurdle is spotting people with vague or non-specific symptoms, those who might otherwise be missed. AI excels at recognizing patterns in huge data sets, which would be impossible for a human working alone.
And breast cancer seems to be a standout example. Is that where AI's had some of its clearest wins?
Yes, breast cancer screening has become a key area for AI. Google's deep learning models, for instance, have outperformed radiologists in both UK and US trials. In one multi-center study, AI reduced false positives by about 6% and false negatives by more than 9% in UK data.
That's more than just a statistic. Fewer missed cancers, fewer unnecessary callbacks. Plus, the NHS is rolling out a cloud-based platform, AirSP, that lets hospitals trial and validate AI tools together rather than everyone running the same tests separately. That could really speed up adoption.
Exactly. The slowdown has always been this scattered, slow validation process. Now, if an AI model proves itself in one hospital, it can be tested across others at the same time. That means faster access to new tools.
Switching topics, Parkinson's disease. I've read AI can predict onset up to 7 years before symptoms show up. Is that accurate? How are they pulling that off?
It's all about picking up subtle signals, changes in speech, movement, even breathing patterns during sleep. Machine learning models can detect these shifts much earlier than a clinician could. Some studies are showing up to 94% accuracy for early-stage detection.
Are these models relying on just one type of data, or are they combining different sources?
The best outcomes actually come from combining sources: neuroimaging, gait analysis, voice recordings. Techniques like support vector machines and neural networks blend all this information together to create a much more robust picture than any single test could.
And this isn't limited to diagnosis, right? These systems can also predict how the disease might progress, or even help tailor treatments to individual patients.
Exactly. AI-driven risk models can inform when to start certain medications or consider surgery. They can also flag patients who might benefit from interventions like deep brain stimulation, making care more targeted and avoiding unnecessary procedures.
AI is also helping coordinate care across specialties: neurology, physical therapy, speech therapy. With natural language processing, it can scan clinical notes, spot gaps in care, and suggest fixes. That's a substantial leap in patient management.
On the technical side, for cancer, convolutional neural networks analyze thousands of annotated images to spot even the tiniest malignancies. For Parkinson's, AI can use home-recorded videos or even overnight breathing data, providing objective assessments remotely.
And the move to cloud-based platforms is central here. It allows large-scale, multi-center validation. That helps tackle a big criticism that AI works in labs but struggles in real-world settings.
That's right, but there are still hurdles. Issues like patient privacy, data security, and bias in algorithms remain. For example, models trained mostly on Western populations might not perform as well elsewhere.
That leads to equity. Can AI help level the playing field between wealthier and poorer countries? Or is there a risk it could actually widen the gap?
It really comes down to access. AI could democratize diagnostics. You could have a smartphone app screening for Parkinson's in rural areas that lack neurologists. But that only works if there's good internet, diverse training data, and local support. If those are missing, AI could end up widening disparities instead.
We've seen both sides already. In some countries, AI is now part of routine breast cancer screening. In others, lack of diverse data or trouble fitting into existing systems has stalled progress. So what's the main lesson?
Thorough, multi-site validation is crucial. No single study can prove a tool will work everywhere. These systems need ongoing monitoring and adaptation to stay both effective and fair.
Let's address trust. How are patients and clinicians reacting to AI being involved in diagnoses?
Reactions are mixed. Clinicians appreciate the support and lighter workload, but there are concerns about transparency and losing that human touch. Patients want to understand AI results and have the chance to ask questions. Involving patients in design and keeping ethical oversight front and center helps build trust.
Looking at the bigger picture, early detection leads to better outcomes and lower costs. Cancers found early are cheaper to treat, and survival rates are higher. The market for AI in cancer diagnosis is set to double in the next decade, so investment is ramping up.
The next 5 years will be pivotal. The UK's Cancer Data-Driven Detection Programme runs until 2030. If these tools meet expectations, we could shift from reactive to predictive medicine, where risks are managed before disease even starts.
The technology's ready. Now the challenge is making sure access is fair, integrating with healthcare systems under strain, and keeping ethical safeguards in place.
The aim is medicine that prevents, not just treats. AI is starting to show real-world benefits, but it all depends on how well we manage the rollout.
So, will AI-driven early detection become routine? And can it reach those who need it most? That's what we'll be following.
That brings us back to where we started. If AI can see disease before we do, what does that mean for the future of healthcare?
Thanks for joining us as we explored the facts and possibilities behind AI's role in medicine.
Thank you for listening. This episode was brought to you by mynews.studio. Try it out for free.